Hello students, now welcome back to the next module of a chapter called electrostatics. Now students, in the previous module we have learned the introduction to the capacitor part. At the same time we have also defined the capacity of the conductor. Now students, in this particular module we'll be starting with the very important concept. Yes, we'll be starting with the concept of parallel plate capacitor. Now before starting with the module, let us first revise few important points that we'll be needing for this particular module, right? Now first important point is nothing but the equation of capacity of the conductor. Do we know the formula? Yes, we have learned it in the previous module, and we know that capacity of the conductor is given by the formula C is equal to capital Q upon capital V, where C is the capacity of the conductor, capital Q is the charge which is given to the conductor, and V is nothing but the potential of that particular conductor, right? Now next point which we require is the concept of potential due to point charge. Now this concept we have already learned in standard 11th. And what does it say? It says that potential at any point due to any charge is inversely proportional to the distance small r between the charge and the point, right? So if I write it mathematically, I can write it as V directly proportional to 1 by r, where V is potential and r is the distance between the charge and the point, right? So as the distance between charge and the point increases, the potential decreases, whereas the distance between charge and point decreases, then the potential will increase, right? Now next important point is that potential is a scalar quantity, and potential due to positive charge is positive, whereas potential due to negative charge is negative, right? Now students, all these points are very important for the concept of parallel plate capacitor, right? So what are the different points? First point is C is equal to Q by V. Second formula is V is directly proportional to 1 by R. That means greater the distance, lesser the potential. Lesser the distance, greater will be the potential. Next, potential due to positive charge is positive and potential due to negative charge is negative. This indicates that whenever I want to increase the potential, I'll be needing positive charge in the vicinity. And if I want to decrease the potential, then I'll be needing negative charge in the vicinity, right? Now let us move further. Now let us start with the concept of parallel plate capacitor. Now to start with the concept, I'll consider first a metal plate P1 which is insulated and it is having area capital A. So let's say I'm having a metal plate P1, right? And this metal plate P1 is insulated and it is having area capital A, right? Let capital Q be the charge which is provided to this particular plate, right? So I'm providing a positive charge Q to this plate, and let's say this plate gets fully charged when it is provided with charge capital Q, right? And let's say V is the potential when it is provided with the charge capital Q. Now we know value of charge, we know value of potential, so I can write equation for capacity of this plate, right? So I can write capacity of plate is given by C is equal to Q by V, where C is the capacity of metal plate P1, Q is the charge which is given to this particular plate, and V is the potential of this particular plate, right? Now let us move further and we'll call it as our case number 1. Now student, if I want to increase the capacity, right, how will I increase? Now see this particular equation, we are having C is equal to Q by V. Now if I want to increase the capacity, I can either increase the charge or I can decrease the potential, right? Or I can say, thus to increase the capacity of the conductor, we can either increase the value of charge or we can decrease the value of potential V, right? Now students, if I want to increase the value of charge, so I'll be needing some additional space, right? So that I can place that charge on this particular metal plate. Now in order to create an additional space, we need to increase the surface area of the plate, which is not feasible in this case. Hence, increasing the value of charge so as to increase the capacity is not feasible in this particular case. So what is the next option left? The next option which is left in this case is to decrease the value of potential, right? Thus we can increase the capacity of this particular metal plate P1 by decreasing the value of potential, right? So students, what we have learned, if I want to increase the capacity of plate, either I can increase the value of charge or I can decrease the value of potential, right? But increasing the value of charge is not feasible since we have to increase the surface area of the plate, right? But on the contrary, we can decrease the potential so as to increase the capacity. Now, how we will be increasing the capacity, right? And what will be its effect, right? That all these things will be discussing in the forthcoming module, right? So that's it for this particular module. I'll see you in the next module. Till then, keep learning.